Polynomial graphs is one of my favorite lessons, so I hope y'all enjoy it as well. So we've been talking about like quadratics, and they make the cutest little parabolas, and they are considered polynomials, but there are so many more. X cubed would make a polynomial, x to the fourth would make a polynomial, and so let's investigate some of these other kinds of graphs. We're going to recognize some patterns, and then we can use those to help us answer questions on benchmarks on state tests. So let's start with this table. On the left, I've got the column about the leading coefficient when we're talking about our A value, whether it is positive or whether it's negative. So we've been talking about this quite a couple of times lately. Let's start with even degree. This is one, let's relate it to y equals x squared. 2 is an even number. So just think of everything we already know. If A is positive, so I'm looking at the top row, and we'll look at the even degree column, that first top left graph, it would make a nice happy parabola like this, right? Now, what if it's another even degree? What if it's x to the fourth? Or what if it's x to the sixth? It's going to have a lot of the same characteristics. Mainly, the arrows are still both going up, but it might have some other humps and bumps. So I'm just going to illustrate an example. So what if it looked more like this? It could, I promise it could. So no matter what degree it is, if it's even and the leading coefficient is positive, both arrows, left and right, are going to be pointing up. Now, it could have more curves in it, and in the end, if it has an even degree and it starts with a positive value, both arrows are up. All right, what if it's negative? Let's go straight down. What if it's an even degree but negative? Well, we know now it's just been reflected. So the same would be true. What if it's something bigger? Your arrows are still both going to be pointing down because of that negative leading coefficient. You just might have some extra humps and bumps. Y'all think I'm crazy, don't you? Let's talk odd. So we haven't talked about odd before, but if I asked you to grab a graphing calculator, go on Desmos and graph y equals x cubed, it would graph something like this, where your arrows are going opposite directions. When it is a positive leading coefficient, the left arrow would go down, right arrow is going up, very similar to like positive slope, increasing from left to right. What if it's not x cubed? What if it's x to the 7th or x to the 13th? We're still going to end up with our arrows going opposite directions. There just might be some extra humps and bumps along the way. The bottom one, you guessed it. If the leading coefficient's negative, it gets reflected. So when I graph it, now my arrows are still going opposite directions, but it's up on the left, down on the right, decreasing from left to right. And if it's any other odd number, it would have the same kind of arrow pattern, opposite directions, but it might have some extra humps and bumps along the way. That's the general information that you need to know. We focused on the arrows. If it's even, both arrows go the same direction. Same direction. Let me change my highlighter color here. Let's do blue. If it's an odd degree, the arrows went different directions. Different directions. All right, so let's look at some examples. Come with me. Use the graph below to answer the following questions. Number 1, is the degree of the polynomial in the graph even or odd. You can use the chart above, but really all I need to consider is my arrows. On this graph, both arrows are pointing up. They're going the same direction, and they're both going up. Since they're going the same direction, it's an even polynomial. I have no idea what this polynomial looks like. It could be crazy. It could be wild. But I do know the degree is even. The leading coefficient, is it positive or negative? Because both arrows are going up, it's positive. Think about your normal parabola, smiley face, both arrows are going up, even degree. All right, some definitions are added in here. Number 3 says zeros are where the graph touch the x-axis. Anywhere it touches, it could touch, it could cross, any of that. How many zeros are there? 1, 2, 3, 4, 5. Number 4, relative maximums are any high points, any tops of the mountains. There are 2 on this graph. Relative minimums are any low points. Oops, missed that one. 1, 2, 3. Relative minimums, they are low compared to their neighboring points. There are 3 relative minimums. And then relative extremes is both your high and low points. So adding up your maximums and your minimums. 1, 2, 3, 4, 5. Now on Delta Math, they switch up this vocabulary, they switch up the question. So sometimes they ask about maximums, sometimes they ask about minimums, and sometimes they ask about extremes. So be reading your questions and watch out for those to be changing. Let's do the same thing again. Number 1, according to the graph, is this an even or odd degree polynomial? All I need to look at is my arrows. They are going in opposite directions. Therefore, it is an odd polynomial. Odd, opposite. Arrows are going in opposite directions. Odd polynomial. Is the leading coefficient positive or negative? Well, I can see it's going down from left to right. So it was negative. How many zeros are there? Those are our x-intercepts. 1, 2, 3, 4. It can go through, it can touch, it can bounce. Anytime it touches your x-axis. Relative maximums. Let's see. Here's a high point and a high point. We got 2 relative maximums. Relative minimums, low places. I see 2. And then relative extremes is both. 2 plus 2 is 4. Any highs and any lows. You have questions like that on Delta Math. Second page of notes talks about in behavior. In behavior is exactly like it sounds. It describes what happens to a graph at the extreme ends of the x-axis. What is the graph doing at the ends? What kind of behavior does it have? So we're talking about to the left and to the right. What's our graph doing? Now there is some math symbols that they use, some math lingo. So I think take that nice and slow. When they say x with the arrow and the infinity, that means as we're going to the right, and it's read as it is read as x approaches infinity. When you have x arrow negative infinity, that's talking about to the left. And it represents as x approaches negative infinity. Let me show you how this works. What is the end behavior of each graph below? The first one on the left, you've got a lovely graph. And the first statement says, as x approaches infinity. As x approaches infinity. That's on the positive side. That's a positive infinity. As it keeps going to the right. What's the y doing? All right, so on the right side, I'm going to look at my arrow, if it was to keep traveling right, which direction, up or down, is it going to go? It's going to continue to go down. Or, let me finish the statement, y approaches negative infinity. I'm going to label it here as well. It's going down to negative infinity. Second statement, as x approaches negative infinity, that's to the left. As the graph goes left, my left arrow, what's the y value doing? Is it going up or is it going down? It's going up to infinity. So finish the statement there to show y is approaching infinity. Let's try it again. Number 2, as x approaches infinity. So on my x-axis, as it goes to infinity, that's to the right. Ooh, look here. Delta Math used a different notation here. This still means y. Let's see what the y values are doing. So I'm looking at my right arrow. It's going down. So my y, or my f of x, is approaching negative infinity. Take these slow because sometimes Delta Math will switch the order. As we're looking at these statements, sometimes they switch the order of these. They might say as x approaches negative infinity first. So watch out for that. Make sure you're just reading these nice and slow. So in green down here, as x approaches negative infinity. So here we are going left. I'm going to look at my left arrow. My y values, that one's going down as well. So y is also approaching negative infinity on that arrow. Both arrows are going down. Both y's are approaching negative infinity. But like I said, Delta Math switches the order. So they might, on both of these examples, I'll highlight it and show you. Both of these examples that I pulled from Delta Math, they mention right first, but sometimes they will mention left first. So read those and look out for that. Now we're going to look at sketching the graphs of our polynomials. This is such a handy tool. We're going to see lots of polynomial functions. We're going to have to match them with graphs, or we're going to be given a graph and have to match it with an equation on our state tests. So this is a very helpful skill to know how to sketch these, at least get a picture in our mind what it looks like to help narrow down our answer choices. So to sketch a graph of a polynomial, you need to know a couple things. You need to know the degree. You'll need to know whether it's positive or negative. Is that a value? Is it starting with positive or is it starting with a negative? And then you'll need to be able to identify the x-intercepts. To find the degree of a polynomial in factored form, and all of your examples we're going to work with right now are in factored form, you add the exponents of the variables. So here's an example. F of x equals x times x minus 2 times x minus 3 squared. To find your degree in this factored form, add up all your variable exponents. There's understood 1 on that x, understood 1 on the parentheses, and then you've got your squared. Add them all up. Gives you 4. You even have a note here. Remember, if there isn't an exponent written, there's an understood 1, and we got a 4th degree polynomial, which is even, which tells me the arrows will go in the same direction when it's graphed. Yes? Yes. To find your x-intercepts in this factored form, you'll set each expression in the parentheses equal to 0 and solve, or you could also just pull the opposite value of what you see in your parentheses. Let me show you on this first one. So if I have the function f of x equals x minus 3 times x plus 2 times x plus 1, the x-intercepts, it said I could take the expression and set it equal to 0 and solve. That would give me x equals positive 3. Or I can just pull the opposite sign. So not negative 3, but positive 3. On the second parentheses, that is going to represent a negative 2 x-intercept. And then the last parentheses, x plus 1, gives me a negative 1 x-intercept. So you got factored form. The x-intercept is an opposite sign. So we're going to use all of that information to just sketch it. Just sketch a polynomial, like I said, in order to match it on a multiple choice test, on a state test, EOC. So let's start with number 1. F of x equals x plus 3 times x plus 1 plus x minus 4. What is the degree? You would add up all your exponents. There's understood ones there, so we have a degree of 3. That tells me this is an odd polynomial. And from our table at the very beginning of the notes, my arrows should be going opposite ways for an odd polynomial. The second thing I need to know is it positive or negative? Just at the very beginning of your function, look and see if it's positive or negative. This one is positive. So I already know my arrows are in opposite directions, but it should be down on left and then up on right to show positive odd. Then what are the x-intercepts? Well, we had x plus 3, an x plus 1, and an x minus 4. So those x-intercepts are going to be negative 3, negative 1, and positive 4. Let me go and graph those. Negative 3, negative 1, and 4. And let me also add my arrows. I know our arrows are going opposite directions, down on left, up on right. And now you can sketch it. Now it's not going to be perfect. It's going to be close. It's going to be close enough for us to match on a test. So I got arrow down on left. It's going to cross the x-axis, and go through the 4 as well and head up to give me an odd, positive polynomial that has x-intercepts of negative 3, negative 1, and 4. Let's do it again. I really like doing these. F of x, number 2, f of x equals x times x plus 2 times x minus 3. Like the example above, you do have an understood 1 on your x, and on each of these parentheses, add those up, that's a 3. So we do have another odd polynomial. The arrows on my graph will go opposite directions. Is it positive or negative? I don't see anything, so it's positive. And then identify my x-intercepts. It was x times x plus 2 and x minus 3. That x, on the notes, it said you could take each factor and set them equal to 0. That x represents a 0 x-intercept. Don't forget him. He's important. The x plus 2 gives me a negative 2, and x minus 3 gives me positive 3. Let me graph those. Those are my x-intercepts. I know that I'm a positive odd. My arrows should look this way. Odd. The arrows go in opposite directions. Positive, so it's going up from left to right. And let's finish sketching it. So my arrow is down. It's going to go through my x-axis and go up. It looks okay. It's just a little sketch. Last and final page, guys. I know these notes are a little bit longer, but I definitely wanted to show you all the examples, and the graphs take up a little bit of space here. So let's finish this off with number 3. Find the degree. Ooh, this one's a big one. You've got a negative in front. Wait on that. I've got understood 1 exponents on all those parentheses, which adds up to 4, giving me an even number. So this is an even polynomial. My arrows will go the same direction. We already saw that negative in front. So my arrows are both going in the same direction, but they're going to be going down because this function starts with a negative. And what are my x-intercepts? Negative 3, negative 1, 2, and 5. Let me plot those. All right, let's sketch it. So I know where I'm starting. My arrows are down. I'm going to go through, and back down. So my arrows are both pointing down for even and negative, and I've showed those x-intercepts. Notice the bold and the star. even exponents bounce. What, Miss Brian? Bounce at that intercept. So instead of going through, they're going to kiss, they're going to touch, they're going to turn away, they're going to bounce, whatever you want to call it. They're not going through, but they are going to hit it. So when you look at number 4, we have x plus 4 squared, x plus 1 times x minus 2. So let's get our degree. We've got a 2 plus 1 makes 4. That's even. The front of my polynomial is positive. My x-intercepts, -4, -1, and +2. All right, we said this was an even, so both arrows are going the same direction, and positive, both arrows are up. I like to show my arrows where I should start and stop. Now, do not forget that x-intercept of -4, that was a bounce. It had an even. So even if, I don't really mean even if it, I'm making something up, had a 4 would bounce. If you saw a 3, that's odd. It's not going to bounce. Okay? So let's draw our graph here. Arrow is up. We are going to bounce at that -4. Don't go through it. Go and touch it, and bounce away. Whoop! Go through and through. You should have 2 arrows up. You should have touched the -4 and then turned away and then go through and up. Yes, I like when they bounce, but we often miss them. We often overlook them because we don't see them that often. I promise on EOC, you're going to have a bounce, I bet, just because they're going to go, are you going to know? Are you going to know? Last 2, I pulled directly from Delta Math because, again, I think our students get to Delta Math and they're like, what is all this? Pull everything that we know, everything we just talked about, and match it with our graph. Let's look at number 5. You've got a beautiful graph. I'm going to zoom in here, see this a little bit closer. Looking at this first answer choice, looks like my x-intercepts are 0, +3, and +4. Okay, so let me see what my intercepts are on my graph. On the graph, it says -4, 0, and +3. Well, that first one doesn't work, does it? We need -4. All right, I'm going to look at bottom left. I've got 0, -3, and -4. I need a +3. Top right, 0, -3, +4. Oh, so close. Hopefully the last one, 0, +3, negative. There it is. There it is. That bottom right one finally represents the correct x-intercepts. Number 6. Can I do the same thing here? We've got a -3. Now watch out. That's a bounce. Whoop, whoop. And then over here at 2. So we've got x-intercepts of -3 and 2. What would that factored form look like? Well, if it's bouncing, that means I had an x plus 3 squared and x minus 2. If it was squared, that means there's 2 of them. I've got an x plus 3 and another x plus 3. There should be 2 of them. So it's squared, so it'll bounce. So let's see here. X plus 3, and the -2. I think that one might be it. Let's double check. -2 or x minus 2. I'm misspeaking. I'm sorry. X minus 2, and then no, those should be x plus 3s. Top right, x plus, nope, no, yes, the first one. There you go. That one worked. So use everything you know about x-intercepts and match those. They're not that bad, I promise. I wanted to show you those on our notes. So I know this video was long. I know these notes were a little bit longer than usual, but guys, there's a lot of information here, It's not hard information. It's not difficult stuff. There's just a lot to it when it comes to polynomial graphs. And guys, this skill is going to be so helpful for us as we work through the curriculum, as we get ready for testing. You're going to love it. I love polynomial graphing. I love doing the humps and the bumps and bouncing and going through. And so I hope you enjoy it too. Practice it. Let me know if you have questions, because if you don't love it, maybe I can help you to love it. Yeah. Okay. I'll see y'all in class, guys. Have a good day.